Okay, given that y equals x squared plus 6x, find dy dx from first principles. So when you see that they're first principles, okay, then you've got to go through that idea, quite a long process to actually get to the answer. Okay, if you just differentiate this and say, oh, it's 2x plus 6, you'll get 0 marks. Okay, you've got to do it by first principles. So what I do is, I've started this here now, I just draw a little bit of a curve and I mark off 2 points. Right, P there, okay, which is where I'm actually going to work out what dy dx is for P, right? That's what I'm thinking. But what I do then is I choose another point which is further along and I call that Q. Okay, now my point P, right, I consider that point to be my sort of general point X, okay? So in terms of my x-axis, right, I'm going to just think of this as my general x value. So x there. So whatever x is, of course, to work out y, I've got to put it into the equation online, which I've got up here. So I put x in, you know, if x was 3, I'll put it in, and I'll do 3 squared plus 6 times 3, and I get the answer out for y. But in this case, I'm just thinking of it as x. I'm just putting x in. And if I put x in, I get this line, x squared plus 6x for my y, okay? And then what we're going to do then is we're going to go to the point Q. Now, point Q is a little bit along, right, along the x-axis. And the way I describe Q is, I think of it as my point X plus a little bit more, yeah? Obviously, it's not X, isn't it? Because this is where X is, this point here. I've shifted along, right? I shifted along, and I'm going to say I shifted along a distance h. So I'm going to call that X plus h. That's my X value, right there. Hopefully that makes sense. Okay, because here's my X value at P, but I've gone along a little bit the X-axis, so I've added a little bit onto X. It's distance h. That distance represents h, of course. Now, if this is my X value at Q, I need to work out what my Y value is, yeah? And remember, to work out your Y, you just put whatever your X value is into the Y, okay? Into the function here, okay? To actually work out what Y is. So if I put this value of X here, X plus H, into this curve equation here, okay, substitute it in, I'll get my Y value. So I'll end up putting in there, I'll have X plus H, all squared, okay, so that's what I get when I put it in there, X plus H all squared, plus 6, and then there's X there, so I put the X plus H in. Okay, close bracket. Now, I'm interested in the gradient of P, but what I'll do instead is now I'm going to work out the gradient of the chord joining P to Q, because I can do that, can't I? I know how to do that. The gradient of the chord P to Q is just using the y2 minus y1, which I've learned before, okay, over x2 minus x1, because it's a straight line, and I can work out the gradient of a straight line if I know 2 points. So I know these 2 points, P and Q. So y2 take away y1 on the top. So now if I call this my y2, my second y value, I'll have this. Take away then my y1, which is my first y value. Now I want to take away all of that, so I'm going to put in a bracket to say I want to take away all of it. All over then, on the bottom, my x2, which is this value here, yeah, x plus h. Take away then my x1, which is just x. Now we'll find nicely now on the bottom, these x's will cancel, that x there and that x will cancel, because x minus x is 0. So you just left with h on the bottom. On the top then we need to take our time. We've got x plus h squared here, so that'll be x plus h times x plus h. Okay, we'll write that out twice. I'm going to do FOIL now. And on this then we've got a single bracket, so we do 6x, 6 times x is 6x, and then 6 times h is 6h. And then that minus, don't forget then, applies, we're taking away all of it. Okay, so we minus x squared, and then minus the 6x here. And what you'll find nicely then is that 6x, that minus 6x cancels with that positive 6x. 6x take away 6x is 0. All over then, don't forget to divide by what we've got left here, which is just h. So on the next line, I'm going to multiply out this bracket here using FOIL. So first x squared. Outers x times h is xh. Inners h times x. I'll just write xh again. And then last h times h is h squared. Okay, and then don't forget what I've got left here then, plus 6h, and then minus x squared. Okay, all over h. And what you'll find then again nicely, that minus x squared will cancel because we've got an x squared here. Okay, and we're left on the top then with 2xh xh and xh is 2xh plus h squared plus 6h all over h. What you'll find then with this method is, on the top, right, there's a common factor of h. H goes into every term. So what I do is I factorize the top, I take out h, and I ask myself then, what do I times by h to get that? So it'll be 2x. What do I times by h to get that? It'll be h. And then what do I times by h to get that? It'll be 6. All over then h. And then because you've got a h on the top as a common factor and a h on the bottom, they will cancel. So I get 2x plus h plus 6. Okay? And I need you to remember then that this is the gradient of the chord PQ. Gradient of that chord there. Okay? But what I actually do want to remember is I want the gradient of the tangent. And if I got the gradient of the tangent, I actually get what we call dy by dx, yeah? The actual derivative. But to get the gradient of this, what I need to do, I need to get q so it's closer and closer and closer to p. In other words, I need to reduce the value of h. If I reduce the value of h, q will get closer. If I just move it a little bit, you can see it's getting closer there. If I make h even smaller, bring it closer still, h even smaller, closer still. So if you notice here now, as q gets closer and closer, this line is sort of getting less steep and less steep, and it's actually getting to form close to that gradient, that tangent there. Okay, so as I get closer and closer and closer, it actually becomes that tangent. And the way we describe that is, right, we say the limit as h goes to 0. So we're interested as h goes to 0. We're limiting h, if you like. Think of it like that. We're limiting it to 0 of this. You need to write this down to get the marks. H goes to 0. You end up with just 2x. H is 0 plus 6, which is, what, of course, what we expect to be the derivative of x squared plus 6x. Okay? But you must write all of this in the exam. You must put these steps in at the end to get the marks. Okay? And be clear here in your workings.